All right, so we're going to continue going over some of the problems we did in class, and the next one deals with solving log base 4 of x is equal to 3. Now there's two ways to approach this. One, you could take the inverse of both sides, which would be raising 4 to whatever's on the left side and 4 to the third on the right side there. So you can do that, and you know that log base 4 and 4 to the x are inverses, so these would undo one another or cancel out, and you'd just get x. And on the right side you'd have 4 cubed. And 4 cubed is 64, so x equals 64. The other way you can do it is to look at these as the exponential form of the logarithm. And so you know that this base, you write it down, raised to this exponent is equal to this. And you get the same thing, 64 is equal to x. It's always good to make sure that you go back and check for extraneous solutions. If I plug 64 back in or substitute him back in for x, I don't get a negative number and I don't get 0. So that works out for me there. This next one I would suggest solving first by subtract 7 from both sides. And this gives you negative 2 times e to the x equals negative 2. And so e to the x equals 1. What do we raise e to get 1? Well, it's 0. X must equal 0. Because anything raised to the 0 gives you 1. Now, remember that if we don't write a base here, we're making the assumption that this is going to be log base 10. So if you rewrite this in exponential form, you get 10 raised to the power of 6 is equal to x. And so there's your answer. You could say 1 million, but 10 to the 6, I'll take that for this one. This one, we have to go back to our log properties. Since these are the same base over here on the right side and I've got a minus sign in between them, I can say this is the same thing as the natural log of x minus 1 over x plus 1. And since on both sides of the equation I'm down to one logarithm with the same base, I can use the one-to-one property and say x plus 5 must equal x minus 1 over x plus 1. And then solve for x. So multiplying both sides by x plus 1 gives me this. I'm going to FOIL this out. And then that gives me x squared plus 6x plus 5 equals x minus 1. I'm going to subtract x from both sides and add 1. And then solve by factoring here. So factors of 6 that add up to 5 are going to be 2 and 3. So x plus 2, x plus 3. So x equals negative 2 and x equals negative 3. Now notice when we check these, if I put negative 2 into this right here, I'm going to get a negative 1. And you can't take the natural log of a negative number. Over here it's fine. You know, you get positive 3, but I still have an issue here and actually here also. So x equals negative 2 is extraneous, and the same thing for x equals negative 3. So I don't have a solution to this one because they're both extraneous, so we're going to say no solution. (25) right here, it's a similar thing I'm going to be doing. This is log base 10 instead, so I'll get the log of 7x minus 23 over x plus 1 is equal to x minus 3. I'm writing all over the place down here. And so I'm kind of doing this silently because it's kind of the same stuff we've already done, but factoring this, I get x minus 4 times x minus 5. That equals 0. And so x equals 4 and x equals 5. Check to make sure nothing is extraneous here. So 7 times 4 is 28. Minus 23 is going to give you a positive number. 4 plus 1 gives you a positive. 4 minus 3 gives you a positive. And it's going to be the same for 5 on all three of those. So these are both solutions here. So this one, once again, we're going to use log properties. This is log base 10. We're going to say the log base 10 of x times x minus 3 is equal to 1. So x squared minus 3x equals 1. Now remember, I don't have the log of 1 over here, so I can't just go through and set these two equal to each other. Don't do that. This is log base 10, so change it to exponential form. So it's like saying 10 to the first is equal to x squared minus 3x. And so we get 0, whoops, pen mode went out. 0 is equal to x squared minus 3x minus 10. And so we want factors of negative 10 that will add up to negative 3. And so that's going to be 2 and 5, with the 5 being negative. Since the leading coefficient's 1, I can use the shortcut and say x plus 2 times x minus 5 equals 0. So either negative 2 is equal to x, and or x is equal to positive 5. If we put these back in to where we were at the beginning, you get a negative. You're taking the log of a negative number right here. So this is extraneous. The 5, however, works for both of them. And if you want to think about it, the log should be the log of 5 plus the log of 2 should equal 1. And so when I multiply these, I end up with the log of 10 equals 1. And so remember, this is the same thing as log base 10. So we say 10 raised to the 1, does that equal 10? It does. So that checks out there. For the next one, I'll save you the hassle of listening to me. I'll just kind of solve this one silently. Just multiplying these two, since I'm adding logarithms at the same base. So since we have the logarithms at the same base, we can set the insides equal. So I get x equals negative 7. When I substitute this back in, I'm going to get a negative logarithm right there, because that gives me negative 21 minus 3, which is negative 24. So there are no solutions to this. Once again, these are the same basis, so I'm going to use the one-to-one property. And I get x equals negative 5. Now in this case, once again, it's okay for x to be negative. You just can't take the log of a negative. This gives me a positive 15 minus 1, which is 14. That's okay. This gives me a positive 20 minus 6, which is a positive 14, and that's okay as well. So x equals negative 5 here. For this one, remember that when we multiply same bases raised to powers, we can add the exponents here. So this is like saying 5 to the 2x plus 4x, which is 5 to the 6x. I recognize 125 as 5 to the third, and so 6x must equal 3, so x equals 1/2. And so for this one, notice we're adding now. We're not multiplying, so we can't add the exponents. We can't really, it's kind of a pain to factor this the way it is, so I'm going to let you equal 3 to the x. And so if I substitute u back in everywhere I see a 3 to the x, this is like saying u squared plus u minus 2 equals 0. And now I'm going to factor it with u as my variable. So I want factors of negative 2 that add up to the middle coefficient of 1. You just kind of treat it like you do quadratics, where you do x squared plus x minus 2. If we called it an x, though, it'd get confusing, so I'm going to call it a u. So factors of negative 2 that add up to 1 are going to give me positive 2 and negative 1. So this is like saying u plus 2 times u minus 1 is equal to 0, so u equals 1 and u equals negative 2. Now substitute back in 3 to the x for that u. And you say 3 raised to what power gives you 1? It must be 0. 3 raised to what power gives you negative 2? There's nothing out there. And that should make sense. If you think about the graph of 3 to the x, it looks like this. You have a horizontal asymptote at x equals 0, or y equals 0, and then it goes through the point 0, 1, and goes on up to infinity there. But the y value here is never negative. So there's no x value going either which way that's going to send you down here into the negative realm. So that's not a solution, just x equals 0. Now these are both base 2, so I know I can set the insides to the same, or equal to each other. And you get x equals 7. Substituting that back in, you get positive numbers in here, which is a good thing. So that's our solution. This one, once again, we have base 4. So I have x over x minus 1 is equal to 1/2. And now I'm going to take and put this in exponential form. So it's like saying base 4 raised to the 1/2, which is the same thing as square rooting, is equal to x over x minus 1. So 2 equals x over x minus 1, and negative 2 equals x over x minus 1. And now we solve for x. So one case I get x equals 2. Over here, I get x equals 2/3. So now we just want to substitute these back in, make sure we don't get any negatives. If I substitute 2/3 in up here, I know I'm going to get a negative because 2/3 is less than 1. So if I subtract 1 from it, I'm going to get a negative. So it's extraneous. If I put 2 in, that works here because I get positive 1. And if I put 2 in over here, I'm going to get positive as well. So this is our solution. I'm going to continue this in on the next video. I don't make these file sizes too large, so we're at about 14 minutes now. So hopefully this is helping you out. Keep working hard and keep trying out these problems.